Hi, my name is Siddhant. A little about me. So, my background is in robotics. When I was 16, I broke a national record in India by building India's smallest robot. Since then, I went to the University of Hong Kong, where I became a student researcher. And actually, a lot of my focus was on marine robotics. Interestingly, in my second year, we did a project where we were trying to map coral reefs in the Philippines. And during this project, I saw the bleaching firsthand and I saw the damage firsthand. And that really made me feel that as an engineer, I should focus on problems regarding the ocean. So that's where a lot of the inspiration for Open Ocean Camera came out. In 2019, we flew down to the Philippines where we started working with a Nat Geo subgroup on basically building a solution to one of their biggest problems and actually one of the biggest problems in conservation in terms of bottleneck in marine conservation, which is the Open Ocean Camera. So, followed by this video is a short pitch of the camera itself. Thank you. Hi, my name is Siddhant, and today I'm here to talk to you about the Open Ocean Camera. Now, the problem that this camera is trying to solve is that the collection and processing of images for marine research is actually very expensive and very time consuming. The reason that uh, you know doing this process is so expensive and time consuming is because underwater video, for research at least, is currently taken using a GoPro camera. Now, the GoPro camera runs out of battery and memory every 3 days, which means every 3 days, as a researcher, I need to spend 50 US dollars to rent a boat, rent some fishermen, go out to sea, dive down, and change the battery. Now, this is obviously very, very expensive operational cost. The second issue is that the GoPro has only three recording modes and it records through the night, so I'm wasting almost all of my footage. And the third is that this recorded video, whatever it is, actually has to be watched frame by frame manually for me to ID the animals inside it. This is a manual process and takes many, many hours. So you can see the three main issues. There's a very high cost of operation, 50 US dollars every 3 weeks. There is no flexibility in the current solution, and the manual post processing is very expensive, very slow, and painstaking. Now, this is where the open ocean camera comes in. Our camera makes this whole process 7 times cheaper and 50 times faster. How do we do this? So, our camera actually has a slightly different battery system, which means our camera lasts 3 weeks underwater instead of just 3 days. Also, we have 1 terabyte of memory and we have an app that allows complete timetabling and scheduling. We also use a deep learning and AI that we have built to classify the animals automatically. Now, what this means is that the scientists can use the app to completely decide what shooting mode they want to use. We support 130 shooting modes. And finally, when they get the camera back out of the water, they don't have to manually sit and view every frame because our AI does this automatically. So we convert 3 days of battery life into 3 weeks of battery life. We convert three shooting modes into 130 shooting modes. And we convert 190 hours of manual processing into just 1 hour, which is done automatically. Our solution is 50 times faster than the current solution and 7 times cheaper than the current solution in annual cost. Now, our revenue model is we charge 1,000 US dollar for each camera and we make 50% margin on this camera. Now, our goal is to make this eventually open source the hardware and only sell our AI and software app. We're looking, hopefully, our dream is to, once we have a big enough camera network, is to actually aggregate the data and the images that are being taken by our camera network and become a data marketplace for marine research. To look at our timeline, over the next 1 year, we want to have and deliver 300 to 500 cameras across Southeast Asia. Within 2 years, we want to move to the software model where our hardware is open source and we are only selling our software. And within 3 years, we're looking to start becoming a data marketplace by leveraging the data that's from our cameras and selling it to research institutions. Our solution is by far the cheapest to operate and by far the most comprehensive. Thanks to the cooperation of some advisors that we have who are part of our solution, we have access to over 1 million images taken by National Geographic. And this allows our solution and our artificial intelligence model to be very defensible. And we started with this idea, came up with this idea in January this year, and already we have sold two cameras, and we already have a letter of intent from National Geographic to buy 100 cameras this year. So these are some pictures of our expedition to Sibaltan, Philippines. And our camera, this is actually a manta ray that was taken by our camera. So this is a little about our team. I am Siddhant. I am the technology expert. I'm an imaging researcher at the University of Hong Kong. So I'm handling the technical aspect. Alessandro is a domain expert. He's the National Geographic explorer, and he's worked in the research field for 30 years. So he really knows that space. And lastly, Florence. Florence is a sales and marketing expert who currently works at AIA Insurance. So she knows sales really well and is able to take our innovation and bring it in the real world. So we are looking to raise, over $100,000 this year, and that is why we are applying to the competition. If we can do this, we will be able to change the way marine research works and hopefully protect our Earth in a better way. Thank you so much.